Hello again. My name is Grace Lewis, and I'm the principal investigator for the Tactical Computing and Communications project. So the motivation for this work is quite clear. Mobile systems, people that are operating in the field are using them more and more to be able to perform their missions. But we have to understand that soldiers and first responders operate in very, very challenging situations. First of all, dynamic context. Like Jerry, it was a perfect intro. Everything is changing when people are operating a mission. Limited computing resources. I mean, mobile devices have gotten very powerful over the years, but they're always going to lag behind their fixed counterparts. In addition, battery. Battery research has not advanced to the point that we'd love it to be. It just has not. So they have to deal with limited computing resources. Disconnected, intermittent, limited network connectivity. That's a given in tactical environments. And on top of that, add high levels of stress. Again, like Jerry said, when you have all these things happening around you, there's high levels of stress, and you don't want to be dealing with a mobile system. It's probably the last thing that you want to do. So what we do in tactical computing and communications is that we develop architectures and technologies to provide secure and efficient computing and communications for people operating at the tactical edge. Just to put our results into context, I'm going to be talking very briefly about two pieces of previous work because they feed very closely to our TCC work, and so they're up there. I was hoping it would look prettier, but it doesn't. Okay, so I am very briefly going to talk about our tactical cloudlets work because it's key for our TCC work. This tactical cloudlets work, as Jerry said before, the thinking behind tactical cloudlets made itself into Talos, and we're very happy about that. Also, in case I forget to mention it at the end, because I'm probably going to run out of time, we've also made the tactical cloudlet software available as open source on GitHub. So if you look for KD Cloudlet, I can tell you later what that means, you can find it. The other piece of previous work that I'm going to talk about is some work that we did in a Lens project called on Delay-Tolerant Networking, because that feeds directly into one of our tasks in TCC, which is delay-tolerant data sharing. And finally, that leads into our TCC work, which is where the focus of my talk today is going to be. So tactical cloudlets, what is it? I've heard it called many things. I've heard them call them baby clouds. Baby clouds, sure. Cloud computing at the edge, data center in a box. But the idea is that a tactical cloudlet, from a practical perspective, is a computing node that could be, for example, a laptop, and it has its own wireless access point. So you can think of that's why it's sometimes called data center in a box. Tactical cloudlets have three very important characteristics which make them tactical. First of all, they're forward deployed. The idea is that tactical cloudlets are deployed close to the mobile devices that are going to be using them. They're also discoverable, and that's another characteristic that's important in tactical environments. A mobile device can, as part of our protocol that we created, can say, are there cloudlets around me? And the cloudlets will respond, yep, I'm here, and you would connect to that particular cloudlet. They are VM-based, again, to deal with some of the things that Jerry talked about, to be able to do resource management more efficiently, and that's where the whole cloud computing at the edge concept comes through. Now, what can you use tactical cloudlets for? Many things. First of all, as an infrastructure to offload computation. Why? So the expensive computation doesn't run on your mobile device, it runs on the cloudlet instead, and so you're not draining your battery. And also you get the increased computing power of a cloudlet. Second, to provide forward data staging for a mission. So what is happening here is an example of forward data staging for a mission. You can imagine before a mission, while you're connected to the enterprise or the headquarters, you put all the data and the capabilities that you need out into the cloudlet, and then when you deploy it in the field, you have everything that you need. And sure, there might be some capabilities that need reach back to the enterprise, but the ideal would be for cloudlets who are completely disconnected from the enterprise. Use it for data filtering. And this in particular addresses that whole issue of high levels of stress and high cognitive load, because you can use cloudlets to, as you're receiving data from the enterprise, you filter it down so that the mobile device receives only what it needs and nothing more. And that also takes advantage of bandwidth efficiencies. You can also use them in the opposite direction, especially now as we're going into the Internet of Things, where you're in the field, you're gathering data, and you can use these cloudlets as gathering points for that data before it goes back to the enterprise. So there are many uses for tactical cloudlets, and here are some features that I'm not going to talk about right now, but they will come up in my talk. DTN. In FY14, we did some work in delay-tolerant networking. DTN is a standard, And what we did was we took advantage of the metadata extension blocks that are part of the standard, and in those blocks we included information such that DTN nodes could make smarter decisions about bandwidth efficiency. So, for example, a DTN node can recognize when it's in one of those three states, either connected, disconnected, and reconnecting, and make smarter decisions about what to do at those particular points in time, whether it has to send out messages, critical messages fast, or whether it has to hold back and probably do some data caching. Which leads me to TCC. So I'm going to talk about three tasks. Actually, three is, do any of you have kids that watch Dora? Everything is in threes. That's how people learn. So I'm going to talk about three things, because you can't learn more than that. Okay, so trusted identities in disconnected environments. That's our first task in TCC. So the motivation for this work is the following. At the beginning, I said that one of the characteristics of tactical cloudlets is that they're discoverable, right? So if I have a mobile device and I say, hey, are there cloudlets around me? A cloudlet is going to say, hey, me. You want to make sure that that cloudlet that is responding is a good cloudlet. The other way around, it's also true. If I'm a cloudlet and I see a mobile device that is trying to connect to me, I want to be able to say, yes, that is in fact a good mobile device. I'm going to trust that mobile device. So if you think about the way trust is created in solutions nowadays, very simple, right? You create credentials in advance, and you share them in advance, and then you do some online validation with a trusted third party to make sure that those credentials are correct. Well, in technical environments, you're not always going to have that luxury of connectivity to an online third party to do credential validation. So what we set out to do as part of this particular task was to create a solution for trust and identities that met 4 requirements. The first one was we had to create a solution that did not require connectivity to that online third party because we can't assume that it's always going to be there. Second of all, we didn't want to place any specific security requirements on hardware. Why? Because we wanted to be able to support coalitions. We wanted to be able to not have to make assumptions about what hardware is being brought into the field. The third one is that we also did not want credentials to be pre-provisioned on the mobile devices. Not only because we wanted to support coalitions, but also because we can't ensure that the mobile devices and the cloudlets are going to be deployed synchronously, like at the same time. And finally, it had to address the threats of a tactical environment. In fact, the first part of this task was to develop a threat model for tactical environments, actually using some of the techniques that Forrest talked about this morning. So we developed a process. I'm really violating the whole 3 thing. This is 4. And there goes to be lots of 4s. So we developed a 4-part process for establishing trusted identities in disconnected environments, in particular looking to address the threats in the threat model. And I want to tell you up front, because it's important, the biggest threat in tactical environments is device capture and impersonation, which is obvious. Is this when I have to move this way? No? Okay. So the first part of the process, we call it the bootstrapping process. So during the bootstrapping process, basically what the cloudlet does is prepare itself or set itself up to become a key generation center. And during that process, using something called IBE, it stands for Identity-Based Encryption. It's work that came out of Stanford many years ago. It's been used mostly in the context of secure email, but here we're using it in a quite novel context. So basically, in the bootstrapping stage, the cloudlet sets itself up to become a key generation center. It creates credentials for itself using IBE, and then it sends those credentials, or part of those credentials, I should say, to a radius server, which is what we use later for Wi-Fi authentication. In the second stage, what happens is a device pairing. So one thing that we have not been able to get away with yet is we have to use, if we want to meet all the threats in the threat model, we have to use out-of-band channels. So the out-of-band channel that we're using here is visual confirmation plus proximity. So in this device pairing stage, what happens is I'm a cloudlet admin. A person comes up to me to a mobile device and says, I want to pair my device with your cloudlet. Upon visual confirmation, the cloudlet manager says, yes, you're an okay person. You can use this cloudlet. Then the mobile device is connected to the cloudlet. either via USB or Bluetooth. I know USB is a no-no. I get it. But we had to do it for testing purposes, as well because it was short range. But what happens at that moment, after the device is connected, is that the Cloudlet, because it's a credential generator at this point, creates credentials for that device and gives it to the device and says, okay, here are your credentials. These are the credentials that you're going to use out in the field. So when that person is out in the field with their mobile device, they would go into the Wi-Fi authentication stage, which is the thing on the left. And so basically, that's what I'm going to do using Radius. So the Radius server already has credentials for the Cloudlet. Oh, and it has credentials for the device itself. So I'm going to authenticate with we'll do Wi-Fi authentication using Radius. So now I can actually access the network. Because remember that every Cloudlet is a data center in a box. It has the computing, but also it has the wireless access point. And after that, every interaction that I do with the Cloudlet is encrypted using the credentials that I just exchanged. And in addition, each exchange is validated against an authorized device list. Why? Again, biggest threat, device loss or capture. So in addition to all that, we had to provide two other things to be able to meet the threats. One is, two ways of doing device credential verification. One is automatic. The other thing that we did is that when a Cloudlet sets itself up as a key generation center, it does it for the duration of the mission. So part of the bootstrapping step is to say this mission is going to last so many hours. Any credential or minutes or whatever you want it to last, but those credentials that I generate at this point are only going to be valid for that duration that I set up. Also, we had to have a manual way of doing so. So for example, if a Cloudlet admin feels that a device has been lost or compromised, the admin can go into the Cloudlet manager and say, I want this device to be eliminated from the list of paired devices. Okay? So this is FY15. Now let's go to FY16. Oh, no. Let's stay in FY15. So how did we validate our work? So how do we know that this works? We actually did three different forms of validation. And one of the lessons learned at the end is this combination of three does work. It works really well. So first of all, we did threat modeling. We did threat modeling, and we said, what are the top threats in this particular environment in which the Cloudlets are going to operate? We were able to identify and prioritize 14 threats, and I have to say that our solution, directly or indirectly, meets 12 of them. There are two that it doesn't meet because it would violate some of our initial requirements. So one of the threats was altered software. We don't address that threat because we would have to rely on something like TPM, and we said no TPM, no hardware. And the other one was daisy chaining. So imagine a mobile device connecting to another mobile device connecting to a Cloudlet. You can implement controls such that a mobile device can't do that, but we didn't do it. So our solution addresses 12 of the 14 threats, directly or indirectly. We also did vulnerability analysis, and actually that's the attack tree that we used to validate the solution. I'm not going to go into that, but that also worked quite well, and we did it against the threat model. And the bottom is something called ceremony analysis, which also worked very well. So in ceremony analysis, nothing is out of band. You study everything from how the passwords get to the admin, how the passwords get to the mobile device owner, everything. Nothing is out of band. And that also helped us develop what we consider as a pretty strong end-to-end solution. Now, one of the features that is supported by tactical Cloudlets is VM migration. So imagine the scenario on the right where you're a soldier, you're interacting with a Cloudlet that's in a tent, it's a fixed Cloudlet, and all of a sudden a vehicle comes along to take you somewhere. That vehicle is also running a Cloudlet in a computing node on the vehicle. You would want to be able to take the computation that you're executing on this Cloudlet and be able to move it to that other Cloudlet, right? So you can continue working. Now, this is all good, but we also have to do it in a secure way, right? So what we developed was, again, we extended what we did for the previous part, and we developed yet again another 4-part solution, where what we do is very similar to what I just explained, but instead of doing it between a mobile device and a Cloudlet, we do it between Cloudlets. So the only way we could address the threats was using out-of-band channels. We would love to get out of that, but so far we haven't found a way to do it. So the first thing that happens is Cloudlet pairing. So in Cloudlet pairing, the two Cloudlet admins get together and over voice, radio, or just talking to each other say, okay, the Cloudlet manager generates some random credentials and say, okay, these are some temporary credentials or keys that we're going to use to create a temporary secure channel, and we're going to use that temporary channel to exchange credentials. After we've exchanged credentials, channel is destroyed. So that's the first part of creating trust. After that, the original Cloudlet, let's call it Cloudlet A, now has a way to access Cloudlet B. So it discovers and connects to Cloudlet B, and it starts the migration process. Now, before it can start the migration process, keep in mind that the soldier that was interacting with Cloudlet A was trusted by Cloudlet A. We want to have Cloudlet B also trust Cloudlet A. Does that make sense? Because now I'm moving the migration over to Cloudlet B. So basically at that point, Cloudlet B generates the credentials for that new device, and it sends them through Cloudlet A. So it's almost like transitivity, right? If Cloudlet B trusts Cloudlet A and Cloudlet A trusts, follow me, device, then Cloudlet B trusts device. Got it? Okay. So basically that is what is happening in device credential generation. In the third part, the service VM is migrated. That's actually of all that, that's the simplest part. It's just like one command. And then finally, the device that has the credentials can automatically connect to Cloudlet B and continue doing whatever it was doing before. And last but not least, the third task was delay-tolerant data sharing. So, as Jerry said, and actually many people have mentioned that today, there's a lot of... This is when I move that way. There is a lot... sorry, I was told that if that happened, I had to move over here. Can you still hear me? Because now I can't hear me. Oh, use the microphone. I see. So in the field, there is a large amount of information that is generated and needed. However, again, DIL environments. And what that diagram on the right is trying to show is that bandwidth and connectivity between nodes can vary greatly in these dynamic environments. So what we did was we built on the work that we had done in DTN, in delay-tolerant networking, and applied delay tolerance to create a solution for delay-tolerant data sharing. So in this case, what happens, again, a four-part process, is the following. Imagine there is a person in the field, and that person is interested in, I am interested in files that are tagged with map or IED, right? So we developed a solution that we consider is pretty novel, based on something called broad catching. So that's your buzzword of the day, broad catching. So what broad catching basically is, it's a mechanism for automated digital file distribution that relies on RSS. And it uses RSS basically as basically a publish-subscribe mechanism for data, for the files that it has. And on top of that, we combine it with BitTorrent. So BitTorrent is a communication protocol that enables quite efficient peer-to-peer file sharing. So when you mix those two things together, that's quite powerful. In fact, that combination is widely used for distribution of media files, which are quite large in nature. So what happens when a user says, I'm interested in a file that is tagged in this way, is that because that user is connected to a CDN, a content delivery network, basically the node of the CDN says, let me know if somebody publishes a file with either one of these two tags. So that's the subscription stage. In the publication stage, after a period of time, another user who is connected to another node in the CDN says, oh, here's a file, and it's tagged with map. Again, because we're using RSS, automatically the first user is going to be informed, hey, there's a file out there. Well, not the user, actually, the CDN node. There's a file out there that matches one of the tags that you gave me. And at that point in time, what the CDN node on the bottom does is it retrieves the torrent file for that particular file. Now, what a torrent file is it's a file that basically contains metadata, and it contains how many chunks or pieces each file is partitioned into, and it also gives hints as to what other nodes in the CDN have those pieces of the file. Make sense so far? So basically, that is what is done in the notification and torrent download. And so after the torrent file is downloaded, what happens is that I apologize, it's quite small. These are pieces of the file being represented here. Basically, after the BitTorrent client receives the torrent file, basically the protocol takes care of everything. It grabs the pieces of the file from wherever it can find them, whatever it considers to be more efficient, and it assembles that file together. And at that point in time, the CDN node pushes the file to the user on the mobile device. So in summary, what we've done in TCC is, like I said before, we develop architectures and technologies that provide efficient and secure communication for people operating at the tactical edge. What we've presented today are 3 pieces of work: our trusted identities in disconnected environments, our secure VM migration work, and finally our delay-tolerant data sharing. And we can advocate as internal users, I guess I could say, that if you combine threat modeling with vulnerability analysis and ceremony analysis, it's pretty good for developing end-to-end secure software systems. And that concludes my talk.